So, bell work day 2, write a probability statement for each of the following events. Okay? A probability statement. Now, I really just, to be honest, put the answer down, but if they want a statement, we need to show probability of rolling a 5, okay? So let's start by doing that. Capital P, and then whatever the event is needs to go in the parentheses, equals, okay, a fair die. We talked about dies yesterday. What is a die? Yeah, it's like a single dice, right? So to roll a 5, how many successes would that be if we rolled? How many faces have a 5 on them? 1 out of how many total? 6. So your answer is not just 1/6, but because they wanted the statement, the probability of rolling a 5 is 1/6. How many had 1/6 though, at least? Good. All right. Now let's think about this. The probability of rolling a 2 or a 3 on a fair die. So here we go. Probability of rolling a 2 or. Now, what symbol did we use for or yesterday? Was it the U shaped or was it the N? It is the U. Think of union. We are for the union. And 4 has the word or in it. So the probability of 2 or a 3 on a fair die. Okay? So we are for the union. Remember, that's the probability of getting a 2 plus the probability of getting a 3. You might want to write this down. Minus the probability of getting a 2 and a 3 at the same time. That's a little confusing. But a 2 or a 3, how many faces have a 2 or a 3 on them? 2 out of the total of 6. Which, if I simplify, divide by 2 over 2, is going to be 1 out of 3. 1 out of 3. Okay? So does everybody understand to write it down when you have the word or, that's a U. Think of we are for the union, and 4 has the word or in it. So we have to do the U shape for the word or. Any questions on number 1? Because I want to make sure everybody really understands these. Jason, you okay? Okay. All right, so number 2, a bag of marbles contains 3 yellow, 2 blue, 1 red, and 2 orange. What is the probability of selecting a red? Now, before we answer that, do you see how number 1 is different? Because they're asking for a statement. So we had to write the capital P of 5 in parentheses equals. Here, they just want to know what is the probability. So we can just put the answer. All right? Is everybody with me on that? So selecting red. What are my total number of wins for getting a red? 1, right, for the numerator, and then we have to add up my total. 3 plus 2 is 5, plus 1 is 6, plus 2 is 8. So selecting red is 1 out of 8. How many had 1 out of 8? Okay, those that didn't, you know what you did wrong. All right, here, let's take a look. Selecting blue or yellow. That means, what is the probability of selecting blue? Well, how many blue wins could we have? 2. Plus, how many yellow wins could I have? 3. And I would need to subtract any place where I have a blue marble that's also yellow. Would I have a blue marble that's also yellow in this case? No. So we're not going to take away anything. So that gives me 5 out of a total of how many? 8. So that one would be 5/8. Yeah. Okay. Maybe. Yeah. All right. Selecting green. All right. How many successes? How many wins do I have with green? Leilani. 0. And 0 out of 8 is going to be 0. What kind of an event is this if the probability is 0? Yes. Was it improbable or impossible? I don't even remember. Okay. Yes. So when we have a probability of 0, we call that an impossible event. They didn't ask us that. I'm just trying to get you to remember all these little things. Okay? All right. Any questions about any of those? I am still recording this, trying to get them uploaded. Okay? All right. Let's go in your packets to page 11. Page 11. And ooh, that's not the right one. You guys do not want to go back to quadratics, I'm pretty sure. All right. We left off, I believe, where we were going to have the teacher deliver something to the office. Didn't we finish the and probability, the or, and the not probability? I believe. Okay. All right. So it says, your teacher needs to pick a student to deliver something to the office. Use the students in your classroom to help you answer the following questions. Okay. First of all, we have to know how many total students we have in here. So look around, count the students while I finish writing this pass, okay? Count the students in here. That was quick. You're supposed to go slower. No, I'm kidding. Daniel, come here. What's going on? Good morning. What's going on, Daniel? Huh? Just this morning? Did you eat breakfast?
I mean, this was helping a little bit.
Okay. Thank you. Mm-hmm. Hope you feel better. All right, so 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But then Daniel just left, and Ranisha just came in, so I think it probably was 14. All right, so 14 is the total. Where is my total always going to go? In the denominator. So we have 14 students total. This is page 11, the bottom half. Okay. All right, what's the probability that the student chosen is wearing a black top and is a junior? Okay. So they have to have both of them, all right? First of all, this is an and statement. Blacktop and a junior. So we're looking for an intersection, okay? So I'm looking for anyone who's a junior that has a black top, an intersection of the two. Oof, that's bad. Intersection. So first of all, we need to look at everyone that has a black top, okay? Jeez, that's a lot of people here today. I would say 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? Now, how many of you are juniors in here? Raise your hand high. High, 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 higher. Starla, that is not high. You are too, Jeremiah? Raise your hand high again. So, Jeremiah has a black top and is a junior. Alex has a black top and is a junior. You're a junior too? Okay. 4. So that's 1, 2, 3, 4, 5. 5 that have both. So when you say and, it has to have both of them. Okay. So that is going to be 5 that have a black top and black top and are a junior. So they had to have both, okay? So we're not adding and subtracting. They have to have both qualities when we use the word and. Any questions on that? Okay. Now, let's take a look at the letter B. What is the probability that the student chosen is wearing a black top, I can read, a blue top or a green top? There's that word or. We are for the union. We want as many people to be a part of the union. So that means I want the probability of those wearing blue plus the probability of those wearing green minus the probability that someone has a blue and a green top. Because we don't want them to be counted in twice. All right, first of all, do we have anybody wearing blue or green? I'm not a student. I don't think we do we? Well, that makes it pretty easy then. So the probability of blue would be 0 plus the probability of green would be 0 minus the probability of someone having both. Out of 14 is going to be 0 out of 14. That's my final answer.
Did I say minus plus blue and green?
Yes, yes. Because if someone has both blue and green on their shirt, I cannot count them twice. Like they would already, let's say Starla has a blue and green shirt. I would put her under the blue category. I would put her under the green category, but I would subtract her from one of these because I don't want to count her twice. Does everybody see that? Guys, eyes up here. One more time. If Starla had a green and blue top on, I would put her in the group that has a blue top. I would put her in the group that has a green top, but I don't want to count her twice, so then I would subtract that she had blue and green, which would cancel these out. That's why we do it for the word or, okay? All right. Letter C, what is the probability that a student chosen is not a sophomore? Is not a sophomore, okay? And that's the probability of not a sophomore. What is the total probability of everything? Maybe I didn't put that well. The total probability of something is going to be a positive 1. Okay? That's your total probability. So the probability of finding someone who is not a sophomore is 1 minus the probability that they are a sophomore. Okay? It's 1 whole because that's the maximum amount of a probability that you can have. So, how many are sophomores in here? Just 1. Are you a sophomore? Oh, are you a sophomore, Micah? You are a sophomore? All right, if you are a sophomore, raise your hand. One more time. So Jason and Jewels, that's it? At least you're admitting it? Okay, so total probability, I'm going to start with 1 minus, we said we had 14 total, right? And we have 2 that say they are sophomores. So how could I rewrite 1 as that fraction? I would rewrite it as 14 over 14. So 14 14ths minus 2 14ths is 12 14ths. What can I divide and simplify both of those with? Dividing by 2 over 2. And I get 6 over 7. So whenever you have a not kind of statement when it comes to probability, you take 1 or the full amount of the probability minus its opposite. Okay? Jeremiah, I really want your head up on this one, okay? Questions on those examples, A, B, and C. Those are really good ones to refer back to, okay? All right, now let's take a look at the table at the bottom. This is the kind of table you're going to see a lot of times when it comes to probabilities, all right? So it says a group of students were asked their favorite sport to watch. Use the table to calculate the following probabilities. All right, so they picked 3 different sports that people like to watch the most: baseball, basketball, football. And then we have a total over here at the end. Okay? So we've got males who like to watch each of those. 13 people like to watch baseball who are guys. 15 like to watch basketball as their favorite sport. 20 like to watch football. This total at the end of the row tells you how many total males we have. Guys, everybody, eyes up here. This is the last chapter test. I really need you to look. The total at the end tells you how many total you have that fits that category. So I have 48 total males. I have 52 total females. And then adding those together, I have a total of 100 participants in that study. Okay? In a similar way, we have that for the baseball, basketball, and football as watching their favorite sport or their favorite sport to watch. So baseball, we had 36 people who said that baseball was their favorite sport to watch. We had 31 for basketball and 33 for football. And if you look at the total this way, again, it adds up to 100. Okay? I call this bottom the total because it should match what we add up here in that last column, and it should match what we add up here in the last row. So this is the total. Okay? All right, so let's take a look at this. The probability of those who said that baseball was their favorite sport. Okay? Well, here's baseball. What is that number who said baseball is their favorite sport? I got to look at the total, right? So it's going to be 36 out of how many total were in this study? 100. So most of the time, you're going to put it over this number that's in the bottom right-hand corner, the total. Okay? Any questions on that first one? And we're not going to simplify it because we're using bigger numbers now. All right? I think I mentioned that yesterday. The second one is the probability that someone, well, their favorite sport to watch is football and they are male. And so it has to be both. If you remember, this symbol is an intersection. They have to have both. And when you think of an intersection, it's where they cross, right? So football and male at the same time. Well, here's my males in green. I'm doing this. And here is those who like to watch football best. Where do those two lines intersect? At the number 20, correct? So that means your numerator is going to be 20 out of the whole total, which is the total, which is how much? Guys, what's my total?
48.
No.
Oh, 100.
100. Yep. 100. Jason, come on. Do you see how that's an intersection? Think of an intersection of streets. It's where the two roads cross. So an intersection here, football and male, they have to be part of both. They have to intersect. Now, the next one is the probability that basketball is their favorite sport to watch or that they are female. So this is an or. Okay? This is or. And remember, that means the probability that they do like basketball, I better put basket because baseball also starts with a B, plus the probability that they are female minus the probability that they are an intersection of both basketball and female, because I don't want to count them twice. Okay? All right, so let me move this off for just a minute. So the probability that someone likes basketball, period. What is that probability going to be? 31 out of 100, yes. So that's 31 out of 100. Plus, what's the probability that someone selected here was female? Here's my female. So that's going to be 52 over 100 minus the intersection. Well, take a look. Once you have drawn those lines, where did they intersect? Here at 16. So I need to subtract 16 out of 100. Okay? So adding these together, they all have the same denominator. So I know it's going to be 100 as my denominator. So then I need to add 31 plus 52. And I get 83. And then I'm going to subtract 16. So my answer is 67 out of 100. And you will see tables done a lot like this. Okay? So we really want to make sure we understand the tables. Any questions on those three? All right, let's go to the next page. We got one more table and then we'll be done for the day. So, number 1 on page 12. Page 12 says, a survey was conducted to find the most popular ice cream flavor. And the flavors were, or what they offered was chocolate, vanilla, or neither. Now, what do you notice here? We have a total for the bottom, but do we have a total over here on the far right side? No, we have to calculate this. So we need to make one more column and talk about the totals for each row. Okay? So I'm trying to figure out how many children do we have? I'm going to take 40 plus 22 is 62 plus 15 is going to be 77. The total number of teens is 12 plus 16 plus 45 is going to be 73. Total adults, 55 plus 54 plus 10 is going to be 119. And the total is 107 plus 92 plus 70, which is 269. Now, I'm going to add these up in this column and make sure they add up to 269 also. So 77, 73, and 119, 12, that's 19, 14, 15, 16, and that is 269. Okay? So if you notice you don't have a total for the last column, you need to make one. If you notice you don't have a total for the last row, you need to make one, okay? All right, so let's try to answer these questions. Letter A, how many people were surveyed altogether?
269.
Very good. That's my total. And again, you're always going to find that in the lower right-hand corner. 269. Letter B, find the probability that someone's favorite ice cream is vanilla. Somebody other than Bjorn.
269.
Very good. 92, because here's vanilla. We're going for the total, so that's 92 out of our total 269. So, letter C, find the probability that someone does not like care for chocolate as their favorite. Does not like chocolate. Well, remember, you need to start with 1 minus the probability that someone does like chocolate. And since I have 269 over 269 minus how many people did like chocolate? 107 over 269. So 269 minus 107 is going to be 162 over 269. Does everybody see how I do the not statements for probability? Okay. Letter D, find the probability that we select teens or, that's the or, remember we're for the union, or that don't care for either chocolate or vanilla. So, if you remember, when you have or, that's the probability of the teens plus the probability of neither minus the intersection of teens and neither. So notice when you have the U, the end one is going to be the opposite symbol, the and. All right, let's do this one in purple. So the probability of teens, go to the end. That's 73. Plus the probability of neither, go to that total, 70. Minus the intersection. Those two lines intersect at 45. Right? So add 73 and 70. That's 143. Minus 45 is going to be, what is it, 98? Yes. 98 over, what's my total again? 269. So everybody see how I did that? When you have the union, you want as many union people as you can. So you add each of them individually and you subtract the intersection. Same thing here for chocolate. See if you can do that one on your own. Find the probability that we selected someone who likes chocolate or that they are adults.
Would that be an adult?
Oh, it is different. Sorry. Yes, you're right. You get smarty for that one. Here I was all excited thinking, okay, here's a good one they can do. That is and. That is and. So we want the intersection of that one. Intersection. So chocolate is 107 and adults, I'm doing it in a different color. The intersection is here at 55. So it's going to be 55 over 269. Thank you, Bjorn. All right, letter F. Find the probability of someone who likes neither chocolate or vanilla ice cream. How about Jewels? What would that be for letter F? What do you think? Probability of neither. Go to your total. So that's going to be 70 over what? What's my total? Yeah, 269. How about the probability that we select a child? Desiree, what do you think? Very good. Always go to the total. 77 over 269. Okay, last one. The union. We are for the union. That is an or statement. So we want the probability of vanilla plus the probability of children minus the intersection of the probability of children who like vanilla. Vanilla and children. So what is my probability of vanilla? 92. It's over 269. We don't have to worry so much about that. We know it's going to be 269. Here's my vanilla, 92. Probability of selecting a child, 77 over 269 minus the intersection of both because we don't want to count those kids twice. So that is my intersection of 22 out of 269. So now we need to do some math. 92, we know the bottom number is going to be 269. 92 plus 77 is 169 minus 22 should be 147. 147. All right. Good job today, guys. So do you see how you have to really be careful and say, is this an and statement or an or statement? All right. Your homework, if you recall, it is on Canvas. It is 7.1. It's not due until Tuesday. And you probably still do not have everything to get started on the whole thing, but you get 5 attempts. And I think if you open it though,